Okay, so in this function, we see a whole bunch of whatever. And how many turns points we see? I have 1, 2, 3, 4, 5. So it looks like this function is a degree of 6. Okay, just like I told you about this one here, the number of degrees and so on. So it looks like it's a degree of 6. So it could be some form of x to the power of 6 or variation of it, plus, or minus. It doesn't matter. We're just sketching this. So where does it plateau? The best thing to do is highlight where the plateaus are. It's here, it's here, it's here, here, and here. And because the slope is 0 at that point, then we'll do a little dot here. We're actually drawing a derivative function from this. So the plateau is 0, so we draw a dot here. The plateau is here, so we draw a dot here. 0, we draw a dot here, and then here, draw a dot here. So we know whatever the function is, it's going to go up and down and cross these dots. Okay? Now, again, use your ruler or use your hand. This is a positive slope. Okay? It's a positive slope from to the left of this dot right here. It's a positive slope. Right? So, well, this has to go up. I know this looks a little funny. Now think about it for a second. Again, this is a positive slope. So this derivative function has to be above 0 because it's positive. So it's a positive slope, all right? And if you look now at the next section here, well, that's a negative slope. So therefore, between here and here, with both zeros, it's a negative slope. So you can just do it like this. And why do I draw it below? Because below the x-axis is negative. Okay, so remember, what I'm drawing is the derivative function. Now look at this. Well, this is positive, and it goes up quite steeply. So you might want to draw something a little bit higher like this. Again, we're just sketching, and then it goes back to 0. Because why? This is a positive slope. This is a negative slope, this is a positive slope. Okay? And obviously, if you look here, this is a negative slope, so it has to dip below the x-axis and then merge up to here again. Again, this is fairly steep, so I'm going it down a bit like that. This slope is positive right here. This slope is positive, so it's a positive slope here. So again, we have to go above the function because above the x-axis is positive. And we go at that. And finally, the slope going down here is negative. So it's a negative slope. Therefore, it's going to go like so. Negative slope goes down the x-axis, okay? Now I'm going to use a different colored. So this is F prime. And now I'm going to draw F double prime. So again, we do pretty much the same thing, except now we're looking at the orange line, the orange curve. Now we look for plateaus again. There's a plateau here in the orange curve. There's a plateau here in the orange curve, here, and here. And we do the exact same thing. So it plateaus here, so it has to be, I'm going to use X this time. Okay, it has to cross over there. Here, it has to cross over here because the slope is 0. Okay, now, like I said, we're doing a double derivative. So again, look at the orange function, treat it like original function, and do the slope function from now. This is 0, this is a plateau, so it's going to cross over there on the x-axis, and here's another plateau, I'm going to cross over there. Again, let's look at the orange function. You can see that this is a negative slope. So this is negative slope, which means this will dip below like that. Okay? Again, look at the orange one from here to here. This is a positive slope, so it has to dip above like that. Okay, and because it's plateauing here, I have to meet with the 0 there. Now look at the orange function here. This is definitely a negative slope and it's quite steep a little bit. So it's going to be negative, so it has to go below the x-axis like that. All right? And excuse me. And then, if you look at the orange here, it's positive, right? So it has to be positive, so up like that. And then finally, it's negative here. So it goes negative down this way. Okay? And it's that simple, really. Now, again, let's observe. How many turning points do we have for this original function? Well, look at the blue one here. It's 1, 2, 3. Yeah, 1, 2, 3, 4, 5. 5 turning points. Let's look at the orange one. Okay, how many turning points do we have here? So, 1, 2, 3, 4. 4. And now look at the double derivative. Okay, which is the pink one I drew. How many turning points do we have? 1, 2, 3. So turning points is 3. So you notice that every time we take the derivative, the number of turning points usually goes down by 1. And like I said, this is probably some sort of a x to the 6 function, whatever. This is probably sort of x to the 5 function. And this is probably sort of x to the 4 function. Now it could be 2x to the 4, it doesn't matter. There's an x to the 4 because of the number of turning points, which is 3. Okay? And then I'm going to do one more example and we're done with this chapter, with this section.